Hi children, we continue with our chapter Carbon and its compounds. Our today's topic is homologous series. Homologous series. It is a series of organic compounds. Organic compounds means compounds of carbon. It is a series of organic compounds with similar structure and similar chemical properties. So, homologous series is nothing but a series of organic compounds with similar structure and similar chemical properties. A series of organic compounds with similar structure and similar chemical properties is known as homologous series. Examples are alkane series, then alkene series, all these we have learned, alkene series and alkyne series. These are examples of homologous series. It is a series of organic compounds with similar structure and similar chemical properties. Examples are alkane series, alkene series and alkyne series. Now, characteristics or features of homologous series. Characteristics or features of homologous series. The first one is all the members of a homologous series can be represented with the same general formula. All the members of a homologous series can be represented with the same general formula. This we have already seen. Same general formula. For example, for alkane series, what is the general formula for alkane series? CnH2n plus 2. So, all the members of the alkane series are represented with the same general formula CnH2n. Then alkene, for alkene series, what is the general formula? CnH2n. Alkynes, it is CnH2n minus 2. So, this is the first characteristic or feature of homologous series. All the members of a homologous series can be represented with the same general formula. For alkanes it is CnH2n plus 2, for alkenes it is CnH2n and for alkynes it is CnH2n minus 2. Okay. Now, the second one is, second characteristic is successive members of a homologous series differ by a CH2 unit. Successive members of a homologous series differ by a CH2 unit. For example, I will write the first members of alkane series CH4, C2, H6. This is methane, ethane, propane we will write, C3, H8, propane. All these we have already written. C4, H8, butane. First four members I have written for the alkane series. Now, what is the difference between CH4 and C2H6? How do they differ? One carbon atom. We add one carbon atom, then you get C2. Then how many hydrogen atoms? Two hydrogen atoms. So, there is a difference of CH2. Now, between C2, H6 and C3, H8. What is the difference? One carbon atom is there, C. One carbon is added, two hydrogen. So, CH2. Here also what is the difference? CH2. One carbon atom is increased, two hydrogen. Sorry, this is C4H10 only. Sorry, C4H10. So, two hydrogen atoms are added. So, successive members of all homologous series. It is easy for you to write. Just write the formula of the first member, then add a CH2. One carbon and two hydrogens are to be added. You will get the formula of the next member of that series. Okay. So, successive members of a homologous series differ by a CH2 unit. That is the second characteristic of homologous series. Now, the third one is the successive members, the difference in the molecular formula of successive members is 14 unified mass. The successive members differ by 14 unified mass in their molecular formula. So, just write for methane, CH for methane, this is a homologous series C3H8 C4H10. Let us calculate the molecular masses, and we have to show that successive members differ by 14 unified mass in their molecular mass. So, CH4, what is the molecular mass? Carbon, it is 12, hydrogen, it is 1 into 4, so 16 unified mass. So, what is the molecular mass of second member? 12 into 2, 24 plus 1 into 6, making it 24 plus 6, 30 unified mass. Next one, 12 into 3 plus 1 into 8. So, what is it? 44. Next, 12 into 4, 48 plus 10. It is 58 unified mass. So, you can see that the successive members differ by 14 unified mass. The molecular mass of successive members differ by 14 unified mass. Okay. Now, the next property. All the members of the same homologous series can be prepared using common methods. All the members of the same homologous series are prepared using common methods. And the last one is the physical properties increase or decrease gradually with increase in molecular mass. So, as you move down the homologous series, there is increase in molecular mass, So, with that, the physical properties, some properties may increase, some properties will be decreasing. So, there is a gradation in physical properties as you move down the group, as there is an increase in molecular mass. So, these are the characteristics of members of a homologous series. First one is, all the members of a particular homologous series can be represented by the same general formula. Alkane, it is CnH2n, that is example. Alkane, it is CnH2n plus 2. Alkene, it is CnH2n. Alkyne, it is CnH2n minus 2. Second characteristic is, the successive members of a homologous series differ by CH2. You write the first member, formula of the first member, add 1 carbon, 2 hydrogen, that is a CH2 unit you add, you will get the formula of the next member. So, successive members differ by CH2 unit. Third one is the difference in the molecular mass of successive members of a homologous series is 14 unified mass. We calculated it and we verified it. Actually, it is CH2, difference is only in CH2, 1 carbon 12. Plus 1 into 2, that makes it 14 unified mass. So, they differ by CH2. So, difference of CH2, that mass of CH2 will give you difference in the molecular mass of successive members. Then the next one is, all the members of a homologous series can be prepared using common methods. Then last one is, the physical properties increase or decrease gradually with increase in molecular mass. As you move down the series, there is increase in molecular mass. With that, there is gradation in physical properties. It may increase or some properties may decrease. Melting point and boiling point, for example, increase with increase in molecular mass. As you move down the series, there is increase in melting point and boiling point. Okay. Now, we will write a question. Just write a question. Write a question. Write the name and formula. Names and formula of the first 5 homologues of alkyne series. Write the names and formulae of the first 5 homologues of alkyne series. So, alkyne, what is the general formula? CnH2n minus 2. First, write the general formula of alkyne series. Okay. Now, what do you mean by homologues? First 5 homologues means first 5 members of the alkyne series. Homologue means each successive member is called a homologue. Okay, so we can write N is equal to 2. First member has N is equal to 2. Alkene and alkane. Please don't be confused. Only for alkane we start with N is equal to 1. Alkene and alkyne, they have double bond and triple bond. So, there should be at least 2 carbon atoms. So, we start with N is equal to 2. So, C2H2. 2 into 2 minus 2. So, 4 minus 2. C2H2. Its name is ethane. Now, how can you write the successive members? By adding a CH2. As we learned, add CH2. So, it is C3. Add 1 carbon atom, making it C3. 2 hydrogens, making it H4. Its name is propyne. Okay. Next, what's the next member? N is equal to 4. C4. 1 carbon atom is added. C4H6. Name is butane. Next, N is equal to 5. C5H8. 2 hydrogen atoms are to be added to the formula of the previous member. So, it is pentyne. And the 6th member is N is equal to 6. C6H10. So, it is hexane. So, these are the first 5 homologues of the alkyne series. Homologues means each successive member. First 5. So, we cannot start with N is equal to 1 because we have to put a triple bond between 2 carbon atoms. So, names and formula of the first 5 homologues of alkyne series. Now, write the second question. Write the name. Question. Write the names and formulae of the first 4 members of the series having general formula CnH2n. Identify this series. Identify this series. So, what is the series having the general formula CnH2n? It is alkene series. Alkene series. The homologous series with general formula CnH2n is alkene series. So, we will write the first member will have N is equal to 2. How many homologues we have to write? 4. So, N is equal to 2. C2H4. C2H4. CnH2n. Its name is ethene. Now, you need not substitute in the general formula. To the first member you add a CH2 unit. Then you will get the formula of the successive members. So, add 1 carbon C3, 2 hydrogens H6, C3H6. Its name will be propene. First and the most important thing is you have to learn the word for first N is equal to 1 to 10. Meth, eth, prop, that series you have to learn. Then you have accordingly you can add ANE for alkane, ENE for alkene and YNE for alkyne. It is butene and N is equal to 5. C5H10. It is pentene. Okay, so these are the first 4 members of the series having general formula CnH2n. This is the alkene series. So, we add ENE. Okay. Now, the next question. One more question we will do. Identify unsaturated hydrocarbons. From the following. following. I will write a few formula. CH4, C2H2, C3H8, C3H6, C4H10, C5H8. How do you find out whether the given compound is saturated or unsaturated? We have unsaturated compounds only alkanes. So, you know the general formula of alkene. So, you have to find out the general formula of each of these compound. If it is CnH2n plus 2, it is saturated. The other two, alkenes and alkynes, are unsaturated. If the formula is CnH2n or CnH2n minus 2, they are unsaturated. Alkenes and alkynes are unsaturated. Only if the formula is CnH2n plus 2, they are saturated. So, answer is unsaturated. You have to find out unsaturated. First one, what is the general formula here? It is CnH2n plus 2. This is saturated. Now, this one, N is 2, N is 2. So, CnH2n minus 2. This is alkyne. So, this is unsaturated. Here, CnH2n plus 2. This is saturated. Here it is CnH2n. This is an alkene. It is saturated. C4H10 is again CnH2n plus 2. This is saturated. Last one, C5H8, CnH2n minus 2. This is alkyne. So, this is unsaturated. So, there are 3 unsaturated compounds, C2H2, C3H6 and C5H8. Okay, so this is how you have to find out the general formula, find out whether they are alkanes, alkenes or alkynes. Alkenes are saturated, the other two, alkenes and alkynes, are unsaturated. Okay, thank you children.